In today's video, we're gonna talk about programmable logic arrays. They are also known as PLAs. What is a PLA? PLA is a fixed architecture logic device with programmable AND gate, which is followed by programmable AND gate. In order for us to program a PLA, there is a minimum of 3 steps which we need to follow. The first step, we need to convert a truth table into a function. In order to program a PLA, you have to convert a truth table into a function. Truth table into a function. The second step, we need to find number of input buffers. Second step, we need to find number of input buffers. The third step, we need to find number of programmable AND gates. We have to find number of programmable AND gates. These are 3 steps which we need to follow in order to program a PLA. Now let's do the first step. The first step says that we have to convert a truth table into a function. Let's imagine we're given the following truth table with 3 variables. Let's imagine we're given this truth table with 3 inputs and 2 outputs. Let's imagine we're given this. Let's imagine we're given this. This is a truth table of 3 variables. Okay. Now we have to convert this truth table into a function. In order to convert this truth table into a function, we firstly have to convert this truth table into a K-map. We take this and convert it into a K-map. Okay. Let's take for the first input. Let's convert the first part into a truth table, into a K-map. This is Y1. Here we have AB. On this side we have C. 0 0 0 1 1 1 1 0 0 1. Okay. Now we're gonna focus on this part only. We're gonna forget about Y2. Okay. When A is 0, B is 0, and C is 0, the output is 0. This is the first part. Output is 0. When A is 0, B is 0, and C is 1. A is 0, B is 0, C is 1. We have a 0. When A is 0, B is 1, and C is 0. A is 0, B is 1, and C is 0. We have a 0. When A is 0, B is 1, and C is 1, we are having a 0. When A is 1, B is 1, and C is 0, we are having a 0. When A is 1, B is 1, and C is 1, we are having a 1. When A is 1, B is 0, and C is 0, we are having a 1. When A is 1, B is 0, and C is 1, we are having a 1. Now, we have to group the ones. Let's group the ones now. We can see that we are having two groups, the vertical group and the horizontal group. Let's talk about the vertical group first. When you look at the vertical group, you can see that AB does not change. It's constant. Therefore, we write AB. But the input is 1 and B is 0. Therefore, we have to write not B. Or let us look at the horizontal group now. When you take the horizontal group, you can see that C does not change. We write C. Also, the horizontal also correspond to this AB. Between A and B, which one doesn't change? Is it A or B? You can see A is 1 and here is 1. B is 1, here is 0. Therefore, we're gonna write C. But in order to write in the correct form, we can say AC. Therefore, Y1 is equals to AB plus AC. This is our first function. Let us do the second function. In order to find the second function, we have again to find the K-map of Y2. Let us now do the K-map for Y2. This is a K-map for Y2. This is Y2. We have AB. This side we have a C. Okay. I'm gonna write 0, 1, 0, 0, 0, 1, 1, 1, and Y0. Okay. When A is 0, B is 0, and C is 0, the output is 0. When A is 1, when A is 0, B is 0, and C is 1, the output is 0. When A is 0, B is 1, and C is 0, the output is 0. When A is 0, B is 1, and C is 1, the output is 1. When A is 1, B is 1, and C is 0, output is 0. When A is 1, B is 1, and C is 1, the output is 1. When A is 1, B is 0, C is 0, the output is 0. When A is 1, B is 0, C is 1, the output is 1. Now we have to do grouping. Let us group the first part and also group the second part. Okay. For this, Y2 equals to BC plus AC. This is the second function, which means we have finished the first part of converting the truth table into a K-map. Okay, into a function. We have find our two functions. Now we have to go to the second step. We need to find number of input buffers. We need to find number of input buffers. Okay. What are input buffers? Input buffer is a combination of AND gates. When you talk of input buffers, input buffer, this is the combination of NOT gates. We call them input buffers. And you must know that number of input buffers equals to number of variables. Because we have 3 variables in our case, therefore we are having 3 input buffers. And the symbol for input buffer, this is the symbol for input buffer. This is the symbol for input buffer. We are having 2 outputs. The first output, which is this one, give us the normal form, and the second output give us the complemented form. Because we are having 3 variables and we have to have 3 input buffers, let us draw all 3 input buffers. This is the first one. Let's draw the second one. And the third one. These are input buffers. Now that we have found the input buffer, we have to go to the third step. We need to find number of programmable AND gates. How many programmable AND gates do we need? The first thing you need to know is that number of programmable AND gates is equal to number of minterms. Now let's count number of minterms. Because for y1 we had AB plus AC, y2 we had BC plus AC. Let us count number of minterms. We have 1, 2, 3, 4. We have 4 minterms, but you can see that we have AC in the first function and AC in the second function. We're gonna omit one AC, therefore we have 3 minterms. Therefore we need to draw 3 programmable AND gates. Let us draw them. This is the first AND gate, the second AND gate, and the third AND gate. Now we have to connect these lines. These vertical lines are minterms. Here it's A, B, C. Therefore we are having A bar, it's B bar, it's C bar. And the programmable out and the output for this programmable AND gates, here we are having AB bar, we are having AC, we are having BC, we are having a BC. Now we have to connect these minterms. We connect them by X or symbol X. For AB, we are having A is connected to B bar. It's A, here it's A. It's connected to B bar. This is the B bar. And we go to AC. Here it's A. This A is connected to C. Here it's C. And for BC, here it's B. Here it's C. It is now connected. The next step we have to do is to connect the programmable AND gates. We need to convert them. We need to connect them to programmable OR gates. This is the last step. But because we are having 2 functions, we'll have 2 programmable OR gates. This is the first OR gate. This is the second OR gate. This is the second OR gate. Now, yes. Now, for the first output, AB is connected to AC. AB is connected to AC. For second output, we are having BC. Having BC. Here is BC. That's all for this video. Hope you enjoyed.